Hello students, welcome to my channel. And in the last video I have taught you how to use log table. So log table you have understood, and I have already told you to download the log table from Google. So today in this video we will learn about anti-logarithm. We have learned everything till now about logarithm. Now we will learn about anti-logarithm, means opposite of logarithm, against of logarithm or opposite of logarithm. So this is in page number 88. Page number 88, anti-logarithm. Log x equals to t. Log x equals to t. When we take logarithm of x, we get t. In this case, x is called the anti-logarithm of t. X is called anti-logarithm of t. So how do we read this one? Log of x equals to t. Log of x equals to t. How we read? Log of x equals to t. So if we read opposite way, opposite direction, if we read in opposite direction, then we read anti-log. Anti-log of t is equal to x. Anti-log of t, x is called anti-log of t. X is called anti-log of t. Just opposite. Log of x equals to t. So anti-log of t equals to x. One more example. Log x equals to 5. So anti-log of 5 is equal to x. Opposite. So it is called anti-log. Opposite of log, so anti-log. So for this also, how just we understand about the log table in previous video. So we have used a log table. So here we will use anti-log table. So there is one separate table for anti-log. For log there is a table, already we have learned, and now we are going to get anti-log, so which is related to anti-log table. Okay. So this one I hope you understand. So now we will discuss how to find x if t is known to us. That is, we will discuss the method to find out anti-logarithm. If log 401.7 is equal to this much, then from this we get anti-log of this. So log of 401.7 is equal to 2.60389. So this is log. Then from this we get anti-log of 2.607. So anti-log of 2.60389, we get 401.7. So I hope you understand this one. This one and this one same thing. Log x equals to t. So anti-log of t equals to x. Log 401.7 equals to 2.60389. So anti-log of 2.60389 is equal to 401.7 by definition. This is the definition. This is the definition of anti-log. Note that the characteristic is 2 is denoted by observing the 3 digits to the left of the decimal point of the given number 401.7. Only the mantissa 0.60389 is obtained from log table. So in order to find anti-log, suppose we are to find out anti-log m, we ignore the digits in the left of the decimal. Look here. Here before decimal there are 3 digits. That is why we have got mantissa 2. Actually this one 2 plus 0.60389 actually. This is the meaning. This one is characteristic and this one is mantissa. Okay. So mantissa is main part here. So anti-log of 2.60389, we understand that this is characteristic. Because this decimal goes here. Left side 2 places move, so 10 to the power 2 we will get, as I have explained in previous video. So 10 to the power 2 if we get, that means 2 will be the characteristics. That is what here written. Only the mantissa 0.60389 is obtained from log table. This 0.60389 from where we have got? From log table. Already we have learned this. 2 plus 0.60339, suppose 38939. So 4 digit I am taking. So this one we have got from log table, that we know already. So that is what here written. Only the mantissa 0.60389 is obtained from log table. So in order to find antilog, suppose we have to find out antilog of m, we ignore the digits left of the decimal point of m, and so when we are going to find out antilog, this one will be neglected. This will be neglected. Only we will find out the antilog of this point after point, whatever digits are there, that will be found from antilog table. So mantissa. So antilog is related to mantissa, remember. Decimal, after decimal, whatever digits are there, that those digits are related to antilog table. Antilog table is related to mantissa, this part. 0.60389. This one is related to antilog, remember it. So the examples below, examples are given here. So I will show you with the help of antilog table. Okay. Here for using antilog table to find antilog of 1.6219. We have to find out antilog of 1.6219. We ignore one. As I have already told you, we have to ignore this. This one is not required for antilog. After decimal, antilog is related to the decimal part only, not the integral part. Decimal part is related to antilog, remember that. That means mantissa. So we will consider 0.6219 for antilog. So for antilog 0.00 we consider. So another one it is given, for antilog 0.0131. So this one, that means this will be connected with, so we will take the number this one only, 0.0131. Here characteristic 0 only, no problem. For 0.0131 if we use the antilog table. So in case of antilog minus 3.0125, we cannot use the antilog table for 0.0125 because in minus 3.0125 both the parts are negative, that is it is so. So this is the important part now here. When we get negative, then that will be different. When we get positive, we don't have any problem to find out antilog table. Antilog. With the help of antilog table, we have no problem to find out the value of 0.6219 because the characteristic is positive number. If it is negative number, then it will be different. Look here. If I write minus 7.5, so that means what? Minus is for 7 and for 0.5 also. So as a whole it is negative number. So as we know that decimal part should be always positive. In logarithm, decimal part should be always positive. Already I explained in previous video. So decimal part should be always positive. So from this we cannot find out antilog. For antilog, we have to get decimal part positive. So in that case, here one example is given. One example is given. Why I am explaining this example? Because it is given in the book, so you can understand properly. So antilog of minus 3.0125. So we cannot find out antilog of 0.0125 because this is negative. Minus is there. Before 3 there is minus. That means as a whole this number is negative. So we cannot find out. We have to make it positive first, then only we can do. So antilog this minus 3.0125, we will make it positive now. How can we make it positive? Minus 4 plus 1. Minus 3 we can write minus 4 plus 1 minus 0.0125. Same meaning. Meaning is same. Minus 4 plus 1 is minus 3. This 0.0125 also minus. Negative number. So as a whole this is negative number. So minus 0.125. Minus 3 minus 0.0125. So in place of this minus 3, what is written? Minus 4 plus 1. So that minus 4 plus 1 minus 0.01, from 1 if we subtract 0.0125, we will get a positive number. because 1 is bigger than 1 is greater than 0.0125. So from 1 we will subtract 0.0125. 0.125. 5, 7, 8, 9. So 0.9875. 0.9875. 0.9875. Now we can write 4 bar 0.9875. Now decimal part is positive. Only characteristic is negative. Remember that. When we get negative antilog, we cannot find out antilog directly. If positive, we don't have any problem. Directly we can use the antilog table. We can use antilog table. If negative, as we know, decimal part should be always positive. Here decimal part is negative. I have written here this one, this one. So in order to remove this negative from decimal part, this -3 we have to make it like this. So I hope you understand. -3 means what? -4 plus 1. -4 plus 1 is -3. Minus 0.125. So from 1 we will subtract 0.0125 so that we get a positive number. From 1 is greater number. 0.0125 is smaller number. So from 1 if we subtract this, we get a positive number. Now we will find out the antilog of 0.9875. 0.9875. So this is the procedure to find out antilog with the help of antilog table. So we will use 0.9875 for antilog table. If you see the antilog table, you will find its structure as given below. Now what we are going to find out, antilog of -3.0125 means we have to find out antilog of 4 bar 0.9875. So antilog is this one only, we know that. This one is neglected always. For antilog, this integral part is neglected. We have to take this part only. After decimal, whatever part there, that is related to antilog. So we will try to find out now antilog. Okay. So when negative, when positive, then we will find out. Here one example is given, antilog of 1.4135. Okay. Here it is no problem because positive. So 0.4135. We will find out the antilog of 0.4135 because antilog is related to mantissa. We will find out 0.4135 from antilog table. So let us go to antilog table now. Antilog table. The tables are looking like same, but things are different. I hope it is visible to you. Hope it is visible to you. Anti-logarithm, this is table. The things are same. In the log table, here 10 to 99, no decimal. As we know, log table is not related to mantissa. As a whole number in what is called significant number. 4 digits we will take directly and 2 digits here, 1 digit from here, 1 digit from here. So 3 parts. There is no decimal here. In log table, there is no decimal. But in antilog table, there is decimal. See 0.00, 0.01 like this till 0.99. Till 0.99. Here also same thing. This one, what is the 1.4135? Log of 1.4135. 1.4135. Antilog of 1.4135. We have to find out. This will be neglected as I have told you. Now we have to go to same thing. Like log table only, we have to make it 3 parts. 4, 1, 3, 5. So first will be one pair. Second is single digit. Third also single digit. Same thing here. 0.41. Decimal 41. Where is 0.41? This is 0.41. This one 0.41. Same. Process is same. 0.41 I have marked here. This is point. Okay. 0.41. This is antilog table. In antilog table you will get all decimal number. all decimal, 2-digit decimal number. Here all will be 2-digit decimal till 0.99. There is one more table here till 49 it is. So from 50, from 0.50 till 0.99 another table is there. So process is same. So 0.41 row I have marked. Next 3 is there. So 3, 2588, 2588. I hope 2588. Okay. Here something little different because they are taking 5 digits. So you can take 2588, no problem. Then okay. Then 41 3 we have got. Then 5. So mean difference 5. That is 3. This one 2588. This is 3. So 3 1 9. That means 0 0 like this. 1 9 5 2591. So let us go back now. We have got 2591. 2591. They have taken 5 digits, so you don't worry for that. So 41 3 5. A B C. In A pair. B 3 line. 3 column. 5 column in mean difference. So 2591 we have got. What we have got? 2591. 2591 we have got. I have got 2591. 2591. So therefore in 2591 we put the decimal point just after 2 digits from the left side. From the left side we will put. Now where will be the decimal? That is the question. Where will be the decimal? Look here. You remember that the characteristic is 1 in case of logarithm of a number where there are 2 digits in the left side of the decimal point. Therefore in 2591 we put decimal point just after 2 digits. Here point will be here. 25.91. What was the characteristic? 1. That means 1 digit comes here. Okay, this one if we go back, then what you will have? 2.591 into 10 to the power 1. So 1 will be the characteristic. So where will be the decimal? That depends on the characteristic. If it is 2, then 1, 2, 3. After 3 digit we will put decimal. So decimal depends on the characteristic. So I will show you one more example, then you will understand. So I will explain one more example, then you will understand properly. Antilog of 2.43145. So characteristic is 2. So we have to neglect this one. Our relation is with 3145. 3145. So where is 31? We will see now. This is 0.31. 0.31 that I have marked this line. Then 4 is there. There is 4. So 4. Here we have got 2061. 2061. 31 4 finished. Now 5. Last number, last digit will be for mean difference. 5 is there. So here it will come. Here it is 2. So we will add 2. 2063. So antilog of 2.3145 is equal to. We will add first 2063. 2063. 2063. Now where we will put the decimal? We will put the decimal here. Why? 1, 2, 3, then decimal. Because characteristic is 2. So after 3 digits we will have to put decimal. Characteristic is 2. So we will put decimal after 3 digits. Here characteristic is 1. So after 2 digits we are putting decimal. I hope you understand. So decimal depends on the character. Why? Because if we want to make it standard form, then this is the case. This one, if we want to make it standard form, how we will have 2.063 into 10 to the power 2. Decimal will move 2 digit, 10 to the power 2. So 2 is the characteristic. That is why decimal will be in this place. I hope you understand. Why decimal is in this place, I have explained you. Decimal depends on the characteristic. If it is positive, very easy for us. It is very easy for us. If it is negative, then I will explain you what a negative also. So look here, if it is negative, we have got 2063. Suppose here negative 2 bar it is there. If it is 2, we are counting 1, 2, 3 this side. This side we are counting. If it is 2 minus, so this side will count. This side will count. So 2063, 1, 2, 3, 2 is there. So after 3 digit decimal. So if it is okay, I will explain this one separately, then you will understand. So for time being, I hope you understand. If positive characteristic is there, then you will have to count one more. 2 if it is there, you have to count 3. If it is 4 point something, you will have to count 5. Then you will put decimal. So decimal depends on the characteristics. So whatever now digit is there in characteristic, so that you have to count extra 1, 2, so you will count 3. I have explained why it is that way. Okay. So there is one more example for bar. This one you will have to understand now. If positive number, positive characteristic, we don't have any problem. If negative characteristic, means bar if it is there, then what we will do? Here there is one example. Then find the value of, if log, there is something given, log 314.6 is equal to 2.49776. 314.6. So there are 3 digits before decimal, 3 digits. So 2 point. So characteristic is 2. So this is the value of that log. With the help of log table, they have found already. They have given, this one is given. So find the value of log 0.003146. We have to find out the log of this. We determine the characteristic by method of mention table 1. For mantissa, we use the log table, that we can found log this one, this one. Now we will find out the log of this with the help of log table. Already I explained 3146 will be the for log table. Okay. Here after decimal 2 zeros are there, so there will be 3 bar decimal. When we use log table, after decimal 2 zeros are there, so already I explained characteristics, already I explained. So after decimal 2 zeros are there, there will be 3 bar. So 3 bar. So 3146, if we use log table, we get 0.49776. 0.4977. They are using 5 digits, you don't worry, you can 4978. Okay, 776, let it be like book only. 776. This value is getting from log table. Remember that. Okay. But read the note below and see if you can find the result easily. No. If the significant digits of two numbers are same and are in the same order, then the mantissa parts of the logarithm of the number are same. Only the characteristics are different. Here log 3142 characteristic, log after decimal 2 zeros are there, 3 characteristics. If positive, positive. That means before decimal, if there are numbers, then you will get a positive number. After decimal, if zeros are there, then you will get a negative number. That means bar. 3 bar means minus 3. Minus 3.49776. So this one I hope you understand. Now example number 2. Example number 2. Here it is found. Look here. This 3146, log 3146, it is given here. 49776. That is why it is, I hope you understand this one. When we use the log table, we will use 3146. So log 3146 already it is found here. This 2 has come from for decimal part. But 33146, when we use in log table, we get 0.49776. This is what it is. So this is very easy. So now log 25.59 is equal to 1.4080. Why this 1 came? Before decimal there are 2 digits. So 1 will be the characteristic. Now when we use log table 2559, using log table we get the value 0.4080. This is what here it is given. This is the value from log table. For which value? For 2559. 2559. Pair, single digit, single digit. Already we used, I have showed you in the previous video. Now, we have to find the value of 10 to the power minus 1.5920. 10 to the power minus 1.5920. So let us take x now. Left, it is written, so I am not going to write again. So both sides taking log x is equal to log 10 to the power 1.5920. Again log x is equal to, this power comes back 920. Log 10 we don't write because log 10 is 1. Minus 1.5920 log 10. Log 10 is 1, so we are not going to write log 10 or 1. So log x equals to minus 1.5920 we have got. So as I have already explained, when we get negative number, because this minus sign is for 0.5920 also. So decimal part is here negative. So we have to make it positive. So minus 2 plus 1 minus 0.5920. Then only you can go for anti-logarithm. Because decimal part cannot be negative. In logarithm, decimal part never be negative. So minus 2 plus, from 1 if we subtract 0.5920, here it is written 4, directly written minus 2.4080. 4080. That means from 1 if we subtract 0.5920, we get 0.4080. Or this one we can write 2 bar 0.4080. 2 bar 0.4080. Now log x is equal to this much. Log x is equal to 2 bar 0.4080. 4080. I already explained log x is equal to t. So anti-log of t is equal to x. This one already I explained. This is the formula for anti-log. So and log x equals to 2 bar 0.4080. So x equals to anti-log of 2 bar 0.4080. Anti-log of 2 bar 0.40. And this characteristic is neglected for anti-log. So we will find out anti-log of 0.4080. Anti-log of 0.4080. 3 parts, always 3 parts for log and for anti-log. So we will go to anti-log table now. X is equal to, we will find, and whatever numbers we will get, where we will put the decimal, that is related to negative minus 2. That means 2 bar. Okay. Now 0.4080. 0.4080. Anti-log of 2 bar 0.4080. We will find out anti-log of 0.4080. Where is 40? This is 0.40. Then 8. Then we will see the column of 8. 2559. Yes, 2559. 2559. So 2559. 48, finished. 48. This is the number. Then 0. So 0, no number, nothing is required. So 2559. 2559. 0 is not there in the what is called for Antilog table. There is no 0. So you don't have to write this 0. Okay. 2559. So we have got 2559. 48. There is 0. So in min difference, no 0 is there. So we don't have to go to min difference. We have got 2559. So equals to antilog of 2 bar 0.4080 is 2559. Now question is that where we will put the decimal? 2 bar, only 2 if it is there. Suppose only 2 if it is there, then we could have put the decimal here, this place. If it is only 2, positive 2, 1, 2, 3, then decimal. But if it is 2 bar, then we will not put there. 2559 is the value of antilog of 0.4080. Where we will put the decimal now? 2 bar, so there will be 10. There will be after decimal 10. How? Characteristics I already explained. Here, characteristics already I explained. -2 or 2 bar, same thing. 2 bar, what? After decimal 10. 3 bar, after decimal 20. Only 2 after 3 digit decimal. Only 2 characteristic, only 2 means positive 2 after 3 digits there will be decimal. But 2 bar, there will be 0 after decimal 10. If it is 3 bar, -3 means 3 bar. 3 bar, that means after decimal there will be 20. This characteristics already I explained in previous video. So 2 bar if it is, then actually number is 2559. Let me explain again. If it is only 2, no bar, means no negative, then 1, 2, 3 decimal. So in case of positive, we will increase 1. In case of negative, we will reduce 10. 2 bar means not 20. 2 bar means 1 less 0. Okay. If it is antilog of 3 bar 0.4080, then we will get the value 2559 only. From antilog table 0.4080, its value is 2.2559. But there is 3 bar, so there will be 20. Then decimal. If it is 4 bar, then 1, 2, 3, 3 zeros, then decimal. If it is only 3, then we will count 1, 2, 3, 4, then decimal. I hope you understand. If it is negative characteristics, then we will count left side zeros, but 1 less. If the characteristic is positive, then we will count right hand side, but 1 more digit. If it is 2, we will count 3 more digits, 3 digits. Remember that. So I will show you one more example. Please pause the video, you can note it down. Pause the video, note it down. So I will show you one more example. Antilog of 3 bar 2653. So 3 bar, leave it. This for time being 3 is neglected. We will go to 0.2653. 0.26. Where is 0.26 here? This is 0.26. This line let me mark. 0.26, then 5. So 5. There is 1841. 1841. Then 3. In that same line, 3. So there is 1 only. So this line you don't have to draw, just you can see, check it, then you can write. So 1. So 1842. So antilog of 3 bar 0.2653 is equal to 1842. When there is bar, please keep some space here because you have to put 0. When no bar, you don't have to keep space. Here 3 bar, so you will put 2 zeros, then decimal. I hope you understand now. Is it clear? I hope it is clear. If it is only 3, then we could have count 1, 2, 3, 4, then decimal. That is different thing. One more example. Antilog of 2 bar 1357. So you will write answer. We will go to 1, 3, 5 and 7. 0.13 first. Where is 0.13? Here. 0.1357. 5. So 5. 0.1357. So for this 5 line, this is 1365. 1365. 135 finished. Now mean difference 7. Just 2 only, everywhere 2 only. So 2. 1367. Why we will add here 1367? Here 2 bar. So we will put 1 0, then decimal. I hope you understand now. This one is done. So antilog of any number you can find out now easily from antilog table. So there are two tables. One is log table, other one is antilog table. Okay. Now example number 3. Log 2 it is given. The value of log 2 is given 0.30103. So this is the value. Or please learn the value. This value you should learn. Some of the values log 3, log 2, log 5, log 7, those values you should learn by heart. That will be easy for you to do all the sums for logarithm. Okay, then log 3 also it is given 0.47712. If you learn 0.3010, that much also enough for you. It is not necessary to learn all 5 digits. Only 4 digits enough for you. 0.4771 is enough for you to learn. Okay, then find log 12 to the power 15. 12 to the power 15. So we will go to, so it is power, no? So 15 log 12. So 15 log 2 square into 3. 2 square is 4, 4 is 12. So what you will write now? 15 log 2 square plus log 3. Multiplication is there. Log 3. So 15, 2 log 2, power comes back, 2 log 2 plus log 3. Now 15, 2 into log 2, value is given. So 0.30103 plus log 3, value is given 0.47712. So calculation is done. This one into multiplied and you will add this one with multiply 15. This is got 16.1877. So this way calculation, very simple calculation. Again the characteristics 16 indicates that there are 17 digits in the integral part of 1215. There are 17 digits in the left side. That means 16 point something. That means after 17 digits, there will be 17 digits. That we got already now. Okay. Now, if it is 1, if characteristic is 1, so before decimal how many digits? 2 digits. If characteristic is 2, then before decimal you will get 3 digits. So same thing. Here, characteristic is 16. That means before decimal how many digits you will get? 17 digits. You will get 17 digits before. Whatever numbers before 17 digits you will get after after 17 digits you will get the decimal. That means before decimal you will get 17 digits. If it is 2.5436 like that. Suppose the from the log table we have got the value of 0.5436, we have got something. So suppose 6932 we have got. Suppose I am saying. Then if it is 2, then 1, 2, 3. Before decimal how many digits? 3 digits. Characteristic is 2. How many digits you have got? 3 digits. Same thing. Characteristic is 16. So before decimal how many digits you will get? 17 digits. This is in the left side of the decimal point of 1215. But note that 12 to the 15 is an integer, so it cannot have any factor. Okay, leave it this one. This is not required. Now this is little different. Previous sum direct positive 15 log 2, so it was positive number. Now we are going to get negative number. If it is negative number, what will happen? Look here. Here also log 2 given 0.30103 and log 3 given 0.47712. Then how many there? Then how many zeros are there just to the right of the decimal point? Look here. Here what is the question? How many zeros to the right of the decimal? Means after decimal. After decimal. So I will show you one example. Suppose 3 bar 0.4278. So we have got found the Antilog table, whatever we have used. We have got suppose 5, 7, 2, 1. Suppose we have got like this. Okay. So now 3 bar it was there. So we will put only 2 zeros. Decimal. After decimal, how many zeros we have got? 2 zeros. Why? Because there is 3 bar. How many zeros after decimal? After decimal, 2 zeros. Why? Because 3 bar. Now we will see here how many bar. Here we have got 23 bar. That means 22 zeros. Here 3 bar. How many zeros after decimal? 2 zeros. Okay, that is the question. You have to find out the bar. Then question is that how many zeros they are just to the right of the decimal point. That is how many zeros are there between the decimal point and the first non-zero digit. Non-zero digit. Decimal and non-zero digit. In between how many zeros are there? 2. Why 2? Because 3 bar. I hope you understand. So here calculation is done. Just calculation at what we have to find out 0.018 to the power 13. So this one x equals to this. So log x equals to log 0.018 to the power 13. Okay. So log x is equal to power comes this side 13 log 0.018. 0.018. This one we will write. This one log x is equal to 13 log 0.018. We can write 18 by 1000. 18 by 1000. That you understand, I think. After point decimal 3 digits are there, so 1000. So log x is equal to 13 log 18 minus log 1000. Log x is equal to 13. This one log 18 we can write 3 square into 2 minus log 1000 you can write log 10 cube. Log x is equal to 13 log 3 square plus log 2. 3 log 10. Log 10 is 1, so only 3 is enough. So log x is equal to 13. 2 log 3, just formula only. Log 2 minus 3. So log 3, the value is given. Log 2, the value is given. Just we will put the value, we will do the calculation. after getting the calculation, after doing the calculation, here it is done already, and getting minus 22.68149, minus 22.68149, it is getting there. So I am not going to do the calculation again. You can do the calculation yourself, or you can see from book. Just calculation, multiplication and addition and subtraction only, that you know very well. Now since the whole number is negative, so we have to make it decimal part, we have to make it positive. So log x is equal to minus 23 plus 1 minus 0.68149. That is what written here. This is what written here. Then from 1, if it subtract 0.68149, it is getting minus 23 means 23 bar point 31851. 31851. So we have got a value now. Log x equals to 23 bar. What was the question? How many zeros will be there? 3 bar was there. How many zeros? After decimal, how many zeros? 2 zeros. 3 bars, 1 less. 23 bars. So how many zeros will be there? 22 zeros. Check. 22 zeros. So question is there, how many zeros will be there after decimal? So that is the question. So by looking the characteristics, we understand that how many zeros will be there. Find the cube root of 0.0005. Log 5 it is given. So this is easy sum actually. Cube root. Cube root means, actually we write cube root like this. This is cube root, or this one we can add 0.0005 to the power 1 by 3, same meaning. So find the cube root of 0.0005. Log 5 is given. Log 5, the value is given 0.69897. So x is equal to 0.0005 to the power 1 by 3. Cube root means power is 1 by 2. So log x, both sides you will take log 0.0005 to the power 1 by 3. Log x equals to 1 by 3 is power, so it comes here. Log 5 by log 5 value is given, sorry. So 0.0005. So we have to find out log now. Log of 5, how much? 0.69897. So 0.69897. After decimal, how many zeros are there? How many zeros are there? 3 zeros are there. So what will be the characteristics? 4 bar. That we know already. Log 5 value is there, 0.69897, as it is given here. After decimal, zeros, how many zeros are? 3 zeros. So characteristics will be 4 bar. After the calculation is done, log x is equal to 1 by 3 minus 6 plus 2 minus 0.69897. Why it is actually this 4? In general, what we do? Minus 5 plus 1. 4 bar means minus 4. Minus 4 we can add minus 5 plus 1. Also it is correct. But here it is done minus 6 plus 2, because by 3 you can cut 6. It will be easy for us to do calculation. That is why this is done like this. 4 bar 0.69897 means this is as a whole, it is negative number. So we have to make it, just decimal part we have to make it positive. So in that case, actually we are supposed to do like this, as I have explained you. But if we write minus 5 plus 1, it will be difficult to get cancelled. It is difficult to get minimized. Okay. So 1 by 3.6 plus from 2.69897, it is 2 minus 6 plus 2.69. It is like this. Okay. So it is right directly 0.269897. Calculation is done. So by 3, if we cut 6, we get 2. So minus 2 plus by 3, if we cut this one, how much it is getting? a 0.896323. 0.896323 means by 3, if it is divide this one, 3 8 are 24, 3 9 are 20, like this, it is dividing this one. So 2 bar 0.896323. 2 bar 0.896323. And now this is the value of log x. Question was there to find the cube root of 0.0005 to the power 1 by 3. That means this is x. We have to find the value of x, not log x. So here log x we have got this one. So x is equal to antilog 2 bar 0.896323. So antilog of 2, this is neglected. We will go 0.896 and 3. This part is not required. Only 4 digits. 0.8963. 0.89 it is done already here by antilog table. 78759. 78759 with the help of antilog table. Okay. Antilog table already I explained. Antilog table. What you will check first? First 0.89. Then you will go to 6. Then mean difference 3. So you do the calculation, we have got this one. So 2 bar there is. So 10 only. Then decimal 10.078759 is the answer. Just now one sum was done. So that was that antilog table. We can use this one. This previous antilog table was there from till 49. Here it is there till 0.99. Just now what we have done? This one, no? Antilog of 2.8963. From book we can check antilog of which number? Antilog of antilog of 2 bar 0.896323. 0.896323. So we will go to 896 and 3. 0.896 and 3. 896 and 3. So 89. We will go to 89. Then 6. So 6. 7870. 7870. Only I am taking 4 digits. In the book, it is taking 5 digits. Here 8963. Others 2 parts neglected. No need. Only 4 significant digits are required. 8963 now. So 3 line. There is 5. So 5. So 7875. 7875. Here how much they are getting? 78759 getting. Okay, 78759. That 9 is neglectable. So 2 bar. So 10 then decimal. This is the answer. This is the answer of x. X means what? 0.0005 to the power 1 by 3 is equal to this one. I hope you understand this. So this is example number 5. Last example, I think. Yes. So in the next video, we will start exercise 3.2. So till then, have a good day.